We learned these formulas, and now let's try to use these approximation methods to actually estimate this definite integral. Now, this x minus 2 squared is this graph, and you're trying to have the area from 1 to 3. This is the area in question we want to approximate. And let's start with the left sum, n equals to 4. In any of these methods, you have to start out by calculating delta x, whose formula is b minus a over n, where the interval is a to b, and n is the number of rectangles that you're going to build. So in our case, b is 3, a is 1, and our n is 4. So you get 2 over 4, which is 1/2. Now once you're done with delta x, then it's x0, x1, these endpoints that you have to figure out. x0 is always starting with the left endpoint, so it's just 1. And then x1 is like, you start from 1 and then you're moving by this delta x amount to get to the next one, and then another delta x to get to the next one, and so on, right? So you just keep adding delta x's to get to the next one. So x1 will be take 1 and you add 1/2 to get to the next one. x2 would be taking this one and adding another 1/2 to get to the next one. And then you do x3 equals to 2 plus 1/2 to give you, well, you can write this as 2.5, or you can also write it as 5 over 2. And x4 would be 5 over 2 plus 1/2, which gives you 3. Now, if you look at the formula for the left sum, it actually ends at 1 before the last xn. So you really just needed this much, but because we'll be using this for trapezoidal and also for midpoints, that's why I actually calculated until x4. Okay, now we're ready to calculate the L sum. The formula says multiply delta x, our delta x is 1/2, and then you evaluate the function at x0, x1, x2, x3, just 1 before the last one. Okay? So we plug into this function x minus 2 squared, the very first number, 1 minus 2 squared plus, the next number is 3 over 2 minus 1 squared, plus 4 over 2, or just 2 minus 1 squared, sorry, this should be 2. 2 minus 2 squared. And then lastly you have 5 over 2 minus 2 squared. And the result is that you have 1/2 times 1 minus 2 is -1, -1 squared is 1. 3 over 2 minus 2 will be -1/2 square that, you have 1/4. 2 minus 2 is 0. 5 over 2 minus 2 would be 1/4. And if you add them up, that's like 1.5 by half. It's going to give you 0.75. Alright, now we can move on to part B. Now for part B, there are actually 2 ways we can do this. One is, I explained before that the trapezoidal is really like average of the left sum and right sum, which makes sense because sometimes when the graph is increasing, for increasing graphs, right sums will overestimate while left sums will underestimate. And if it's a decreasing graph, then right sums will underestimate, whereas left sums will overestimate. And because one overestimates and the other underestimates, if you take the average of the two values, you get a better approximation. That's basically the idea of the trapezoidal method. So if you knew that, another approach to get B would be simply calculate the right sum in a similar manner, and then you just take the average, you get the T. But I also want to show you how to actually make use of this formula, so let's just actually just calculate it using this formula there. So for the trapezoidal, we already have all the delta x's and x0 and x1. So let's just use them. Delta x is 1/2, and you have to divide that by 2. And then 1 minus 2 squared is the same, but then it says multiply 2 to the next value. So it's like 2 times 3 over 2 minus 2 squared plus 2 times, and 2 is multiplied to everything in between until you reach the last one before the last one. And only the very first and the last ones don't have any 2 in front. That's because if you add these two, these repeat, everything in between repeats, but these don't have any pair to add up, so everything in between has 2 there, right? Okay, so you have 2 times 2 minus 2 squared, 2 times 5 over 2 minus 2 squared, and this is actually the last one, right? So this is the one before the last one, so the last one would be 3 minus 2 squared, and that one doesn't have a 2 in front. So that's what you have to calculate, which is 1 over 4, and then you can calculate this as like 1 plus 1/2 plus 0 plus 1/2 plus 1, and then you divide times 1/4. You'll see that the answer will come out as 0.75. I'm just trying to save you time, but if you punch these into a calculator, you're going to get 0.75. Now usually the trapezoidal method will be a better approximation to the area than left sum or right sum, but this is like a very unusual case because this is kind of even, one like is symmetric. In that case, the trapezoidal will like if it's concave up like this one, and it's evenly distributed, like the left and right side is like symmetric over that interval, then the trapezoid will also overestimate, and it won't be any better than the other two. But that's like an exceptional case. Usually this is going to be a better approximation than the other left sum and right sum. Okay, so now let's move on to part C, which is midpoint rule. Now for the midpoint rule, you have to find the midpoints, and that midpoint formula is given here. How do you calculate midpoint? This is simply average of two points, right? And you get the average of the 2 points, you get the middle of that. And because the first interval starts from x0 and ends at x1, the midpoint would be x0 plus x1 divided by 2. So let's do x1 star, which is the midpoint of the very first interval, and this is the average of 1 and 3 over 2. And that gives you, well, that's 5 over 2 divided by 2, so it will be 5 over 4. Now I think this is easier if I just say 1.25. And x2 star would be the average between 1.5 to 2. 1.5 plus 2 divided by 2 would be 1.75, right? And x3 star would be 2 and 2.5. You have 2 plus 2.5 divided by 2, that's going to be 2.25. And then x4 star would be, another thing you can see is that this also has a structure that you get to the next midpoint by adding the delta x, which is 0.5, right? This is 0.5. So we could have also obtained the other ones by using that. So you just use this formula for the very first midpoint, and you can just keep adding 0.5 to it to get to the next one. So 0.5 plus 2.25 would be 2.75. Okay, so now we're ready to calculate the midpoint rule, which is the case of, let's see, it will be, midpoint is delta x times, it says delta x, times f evaluated at 1.25. So you have to do 1.25 minus 1 squared plus 1.75, sorry, this is 2, keep saying 1, So 1.25 minus 2 squared, because that's the function. I'm just plugging 1.25 there. And you have 1.75 minus 2 squared plus 2.25 minus 2 squared plus 2.75 minus 2 squared. And then somehow now I like to use fractions. So this is like the difference between these two is 3/4, right? So difference is 0.75, which is 3/4. And it's easier for me to square the 3/4 than 0.75 squared. So 3/4 squared would be 9/16. And then this is a quarter. Difference between these two is quarter. If you square it, that's 1/16. And then you get another 1/16, and you get another 9/16. So let's see, you get 9 plus 1 plus 1 plus 9, that's 20. 20 divided by 2 is 10. So it's 10/16, which is 5/8. And that's going to be, let's see, 0.625. Okay. All right, so so far these are the approximate values that we have. We have these two being 0.75 and this one being 0.625. Now let's move on to the simpsons. And because for simpsons I have n equals to 8, I have to redo the delta x's and everything, okay? Alright, so part D, delta x will now be b minus a over n, b being 3, a being 1, n is now 8, so it's going to be 1/4, or 0.25. And therefore x0 would be, you start from left-hand point, which is 1, and then you keep adding 0.25, so x1 is 1.25, x2 is 1.5, 1.5 plus 0.25 is 1.75, x4 would be 2, x5 would be 2.25, x6 would be 2.5, x7 would be 2.5, and x8 would be, oh, sorry, this should be 2.75, and x8 should be 3. Now make sure that the last one, because n is 8, this is our xn, and this last one does agree with the right end point. If it doesn't, then you made some mistake. Okay, that's why I quickly figured out that, oh, I can't have 2.75 here. It has to be 3. So that's why I looked and fixed it. Okay, and now let's apply this formula. Erase this. This should be 3. Okay, so simpsons is you take 1/4 and you divide this by 3. That's the formula. And then into this function x minus 2 squared, I just keep adding these numbers. It's 1 minus 2 squared, and then 1.25 minus 2 squared. But look, the Simpsons rule has 4, 2, 4, 2, just alternating again and again until you reach the second to last one. Because Simpsons rule only applies when n is even, you always alternate this and end at the same 4. And then the last one will have coefficient 1, right? So you want to put 4 here plus 2 times 1.5 minus 2 squared plus 4 times 4 times 1.75 minus 2 squared. So 4, 2, 4. The next one is 2. And then 2 minus 2 squared. 4, 2, 4, 2. And then the next one is 4. 2.25 minus 2 squared. So yeah, I'm using all these numbers, right? 2.25. The next one would be 2.5. And then 4 becomes 2. 2.5 minus 2 squared. And then 4 times 2.75 minus 2 squared. But that's like the second from the last one, right? The last one is 3, and that last one will have just 1 as the coefficient, and you just have 3 minus 2 squared. Okay? So you can put this into the calculator. I'll just write the answer because I already calculated this before presenting this. And the answer will be like 0.66666, or if you round it up, it will be like 0.6667. So that's the approximate value. The actual value that you get is 2/3. And that actually agrees with the actual value of the integral. So instead of finding the approximate value, how would you find the actual value? Well, we can use the fundamental theorem of calculus, right? You can use integral from 1 through 3 of x minus 2 squared dx, whose integral is you add 1 to the exponent, put the reciprocal in front, and you plug in 3 and 1. And then if you plug in 3, you get 3 minus 2 cubed minus, and then you have to plug in 1, it's 1 minus 2 cubed. And this is 1 cubed, which is just 1, so it's 1/3. Minus negative 1 to the third power is negative 1, so it's like 1/3 times negative 1, but negative is positive, so you end up with 1/3 plus 1/3, which is exactly 2/3. So in this case, the Simpsons gives us the exact value, 2/3, just like the integral. And the reason for that is because Simpsons uses parabolas to approximate, and because the function itself is already a parabola, no wonder it's going to give you the exact value.